Okay, so good afternoon, everyone. I'm honored to present my thesis dissertation. It's titled Efficient Data Management in a BIM-based Framework for Circularity of Products and Materials. It deals with the use of BIM methodologies for management of construction and demolition waste. I'll start with an introduction into the context. So the construction sector is responsible for raw material extraction, environmental contamination, a lot of carbon emissions, and also waste generation. So as you can see in the graph here, that 30% of all generated waste is due to construction activities. This is a result of the linear model of construction, which follows a take, make, and dispose model, where at the end of their life, buildings are demolished and the materials are disposed of in landfills. So we need to shift from this linear model to a circular model, where at the end of their life, the materials that are obtained from a demolition or deconstruction can be used for future constructions. So the use of existing materials in building stock for future construction is called urban mining. A small study was conducted into the building typologies in Portugal to understand the available materials and the major materials that were used. So what we can see is that in the 1900s, buildings older than 1900s was not considered because they might have a heritage value, and newer buildings are not yet suitable for demolition. So the 1900s, the main observation was the use of reinforced concrete and load-bearing masonry walls. So as of 2011, almost 50% of residential buildings were made with reinforced concrete structures, and 30% with reinforced with masonry walls and concrete slabs. So there needs to be a framework to manage the end of life of these buildings, and this work explores the use of BIM to do the same. So I'll talk a bit about the Recycle BIM project, of which the University of Minho is a partner, and it aims to create a framework for using BIM to manage circularity of materials and demolition products. So it includes a scan-to-BIM workflow of demolition and defining information rules for making a model during demolition, and also connection to marketplaces. So the materials that are obtained from a demolition can be sold to customers in the marketplaces. And so these concepts are explored, and the objectives of the dissertation are explained here. So the first part is to establish what information is required from products and materials to make sure sufficient information is available for the marketplaces and for stakeholders to make decisions. And the second part is to define the requirements to make a BIM model so that this process can be facilitated, and also to define the granularity and exchange requirements of the model, which helps to standardize the process, and also validation of the created IFC file using IDS validation workflow. So the first part was to understand the market and the main components of construction demolition waste. So concrete bricks and blocks are almost 80% of all generated waste, but there's also a market for glass and metals, which are already kind of established because they're high value in recycling. And there's also a market for reclaimed doors and windows. There's also European guidelines for construction demolition waste management, and also Portuguese framework as well. So these guidelines specify a bunch of requirements which specify that materials should be classified according to whether it's hazardous or whether it's inert, and also whether it's able to be reused or whether it's supposed to be recycled if it's not able to be reused. And if it's not recyclable, it should be set up for material recovery or energy recovery. And the last option is landfilling. So based on the market study and the guidelines, we define a bunch of circularity parameters. Also, the so this works based on open format IFC. So the capacity of IFC to store information of buildings was also explored. IFC built element was explored as a virtual model which could store information of building elements. So according to the study, there's various types of IFC built elements which have different geometry requirements. Some of them are extruded objects which have a single material with a profile, and some of them, like walls and slab, have multiple materials which have different thicknesses. So each object is stored in a different way. And then there are some assembled objects like curtain walls, which are made up of multiple component materials like a panel and a mullion. So these are the different types of built elements that I explored. And also the capacity of ISC to store property and quantity information was explored. And this figure elaborates how a built element is related to materials, and it's related to property sets and quantity sets, which store its quantity data, and also classification. So this also helps when we perform the validation function, and also when we define the requirements, so that each object has information stored in the right places. So moving on, so based on the studies, product data templates were made for each built element, which defines a set of circularity parameters and quantity information from each element. So based on this, like a door, for example, when it needs to be in the marketplace, the customer should know the exact unit size of the door and window, for example. And if it's a wall which is going to be demolished, we don't really need to know the length and width, but we need to know the volume of the materials that are contained in it, so that it can be resold as aggregates or blocks, for example. So product data templates were made for products and materials because they have different requirements. So the product data template for materials was explored for a few major materials like reinforced concrete and steel and wood, and the various properties that are required from them are also defined here. Also defined is the data type of each property and where it should be stored, so that in the IFC, there is no ambiguity about what type of data is stored and where it's stored. So moving on to the actual model. So to create a deconstruction information model, which is what we are calling this model, which will be used to help us facilitate the demolition workflow. So to do that, the inputs and controls and outputs and actors were identified. Sorry. So the workflow is demolition company will be hired to do an audit. They will do a laser scanning, and as a result of the laser scan, a BIM model will be created. So it will also have information about the building which is already existing, like plans and sanction drawings and stuff. And the controls would be the construction demolition based guidelines and the alphanumerical requirements from the model, the geometric requirements and the modeling rules. And the output is a quantified and classified set of products and materials, which can be fed into the marketplace so that customers can access this information. So to accurately define what the information requirement is, the ISO 19650 defines an exchange information requirements, which has information requirement, which includes project information requirements, organization information requirements, and asset information requirements, and also the level of information need. It includes acceptance criteria, which includes information production procedures and standards like project units and data authoring softwares. So if we define this it's clear for everybody involved that this is the standards that has to be followed. It can also include RACI metrics, which assigns responsibilities to each party. The EAR should also include supporting information, such as existing documentation and guidelines. And also the delivery milestones should be defined so that the goals are set up and the dates for each goal is also set up. So that's all regarding EAR. And then to define the granularity and extent of information to be produced, so that this is a demolition. So it's the end of life. So we don't need to produce too much information, produce excess information. So to control the amount of information that is produced, we can use this framework or level of information need, which defines the level of alphanumerical and geometrical information from each building object, like walls. So this table was made for the major building elements, which defines the geometric requirements from each, such as for walls. It has to be in different layers, and each layer should have a different color. And also the identification, so stating that the object should be classified according to uniclass, and the object type should be IFC wall, for example. This ensures that there's no confusion when we go to the marketplace. So each object is according to a classification, for example. So based on the exchange requirements and the modeling rules and the information need, a model was created on ArchiCAD 26. And it was made sure that based on the information requirements, like walls were modeled with different material layers, with each individual thicknesses. The assembled objects were modeled with component objects such as plates and members, for example. And it was ensured that all the requested information, the circularity parameters, are also included in this. So when we have a larger model, it becomes hard to validate the presence of information manually. So that's when a validation workflow with IDS comes up. IDS is an XML format file where we can specify our requirements from each element, and it will automatically check the IFC to make sure that the information is present in the model. So this was done using an online IDS converter, which is open source, and also edited using Visual Studio Code. So the created XML was checked against the IFC with Blender BIM, which creates a validation report, which states that okay, the walls have this property, the slabs have this property, but this property is missing from these walls. So this report helps us to populate the actual model with the required information, so that the model is it follows the exchange information requirements, and it's not missing any information. So that was the final step. And for conclusion, this is a summary of the work that was done. So defining product data templates for products and materials, EAR based on 19650 for deconstruction information model, the level of information need for demolition based on EN 17412, creating the model in ArchiCAD and then exporting to IFC, and then validation of the file using IDS. Yeah, so this model can be used for the Recycle BIM project for their functionalities. And that's it for my presentation. Thank you.